stats enthusiast. Welcome back to our AP Statistics series on Unit 7, Inference for Quantitative Data Means. I'm Goldie, and I'm ready to take you through the last video in our series, which is going to cover Note 6, which is the calculator commands for the TI-84 and how we can select the calculator commands to perform inference. And we are also going to be doing a skills focus lesson where we talk about how to choose our inference procedure when we are given a problem. So go ahead, sit back, relax, and trust me to take you through this amazing content. The two things we are going to cover in this video today are going to be our calculator commands as well as how to choose our inference method. So first up is going to be our calculator commands, as you can see here. So let's go over all of the inference procedures that we have covered in this unit. Okay, so first up, we have these two, 1 and 2 right here, just the plain z-test and t-test. Now, those are going to be the one sample z-test and the one sample t-test, both for means. Something to help you out with this on the TI-84 here is that whenever there is a prop, that's when you are dealing with proportions, right? Your 1 and 2 prop z-test and your 1 and 2 prop z-interval. Anything else is going to be a test for means, okay? So your z and t test right away, that's going to be for means. Next, you have these 3 and 4. Okay, 2 samp z test and a 2 samp t test. These are going to be the 2 sample test for means. This is what we just went over in the last section of notes on, okay? And then 5 and 6 are going to be your proportions. 7 and 8 are going to be your 1 sample z and t intervals for means, okay? And then 9 and 0 here are going to be your 2 sample z int and your 2 sample t int. So your 2 sample intervals for means. And these are all of the inference procedures we have learned in this unit, believe it or not. Okay. Now, we've gone over 5 and 6 and A and B as well in Unit 6 because those were proportions. C and D are going to be covered in the next unit, in Unit 8, because those are our chi-square distributions. We are not going to cover E in AP Statistics. We are going to go over F and G. That's going to be Unit 9 in AP Statistics. And unfortunately, we do not get to H, ANOVA, for AP Statistics. So we basically are going to know every single test that's in here minus 2. So it's important that you keep them straight and organized in your mind so that you know which one to use. Okay. 8 total inference options for means alone on your TI-84. To help you kind of organize this, we're going to go through a table here in a few moments on what the formula is and what your calculator asks for. For each of these inference methods, though, you'll be asked to either enter data or statistics. Now, data would be what you have already entered into your calculator, which we do a lot of the times in order to graph our sample data for means. So you might have like all of your data points in list 1. And if you do, you can just run your test on all of the data in list 1. Okay. Or if you're just given statistics in a problem, you can choose that option and just enter in those statistics. Remember that the z-inference procedures for means involve the unique circumstance where you know your population standard deviation, which will most likely not happen, okay? So I do go over them and show you them, but just know that you most likely will not use those, okay? And then here's a special note for your 2 sample inference for means, okay? The first one is you do not pool. Okay, I'm going to show you, you're going to be given an option. You're going to say pool, yes or no. Do not pool. Okay, now what is pool? Well, we actually pooled for our population proportions. Remember when we had our population proportion, we had a combined population proportion with our 2 sample proportions. And we did this. Okay, remember doing that? That was technically a pooled proportion, and we do that for proportions. In fact, when we run our significance test or our confidence just our significance test for two population proportions, it automatically pools. So we've never been given the option to pool or not pool, but you will now, and we do not pool for means. Pooling for means would be assuming that in a significance test, assuming that your two population standard deviations are equal, and we can't exactly make that assumption with the inference procedures we are using. So we don't make that assumption, and we do not pool for means, okay? The other special thing that I've mentioned is that when we run our significance test on our calculator uses that crazy formula to give us a combined degrees of freedom, which is going to be a decimal. Okay? So if you do use your calculator to get your t statistic and your p-value, you're going to want to report your degrees of freedom that your calculator gives you as a decimal. Okay? So those are two special notes for the two-sample inference for means. Okay? So let's go ahead and complete a table, kind of like a summary table, for the 4 common T procedures. If you need to pause this to fill it out at all, please pause it, but I'm going to just kind of be going through these here. So our first inference method, the common one, is going to be a one-sample T interval for means. Remember, this is going to be your formula for it, x bar plus or minus T star times your standard error. If you were inputting onto the calculator, you input your x bar, your s sub x, and your n, and then you report your confidence level as a decimal. Your output is going to give you that confidence interval and interval notation. It's going to then spit back out what those statistics you put in were. Okay, so notice that this doesn't give your T star value. It doesn't give degrees of freedom at all. It's just a one sample T interval. Okay, so you still have to know how to do that. The next is the two-sample T interval. This was the formula for your two-sample T interval. So now we just have our statistic being the difference, plus or minus T star, times the square root of the of the variance there. So this time, if you are looking for stats as your input, it's going to ask for both this one and this one, same stuff, 2 different ones, same confidence level, and then it's going to ask you about being pooled. And this is where you put no. We are always not going to pool for our means, okay? Our output now, notice what it gives out. It does give out our confidence interval here, and then it reports that degrees of freedom as a decimal. So that's using that, again, that crazy formula. If you write this down from your calculator, so if you show like all your values plugged in and then you're like, let me run the calculator because I don't want to do that by hand, you can report this as your confidence interval. Please make sure that you report this as your degrees of freedom though, okay? If we were doing that by hand, if we were doing degrees of freedom by hand, we would use degrees of freedom equals 34 because that's going to be the smaller value. Okay. But if we report this confidence interval that the calculator gives us, we want to report these degrees of freedom. If we were to do this by hand, using our calculator, we would report, by hand. I say by hand, obviously you plug the numbers in your calculator, but you report it as something you do by hand. We would use this degrees of freedom. Okay. So make sure you know which one you want to do, and you report it correctly. On the AP exam, they of course accept either. You just have to make sure that you are reporting it correctly. If this was a multiple choice problem, they would word the answers in a way that whether you did it by hand or the calculator, you would get the correct answer. Okay. Now let's look at our test. So we have the one sample t-test for means, and our t-test statistic is going to be this formula. Our input, if we're just doing stats, is going to be our null hypotheses, our x bar, our s, our n, and then our alternative, okay? If you have the TI-84 pluses, remember that this means you can actually draw the distribution and choose that option. But usually we just press calculate because we're just interested in those numbers. Our output this time It's going to report what your alternative hypothesis is, your t-statistic, your p-value, and then also report back what those are. It doesn't give you degrees of freedom, but for your one sample in this situation, it would be 34, okay? And then the last common inference procedure method is your two-sample t-test for means. This is going to be your formula. Your input when you're looking at stats, you're given two inputs, okay? Two data sets essentially. You are going to be asked about your alternative hypotheses. And then again, you have a question, pooled or not pooled, you always click no, okay? Now your output is going to report your t-test statistic, your p-value here, and then you'll notice that degrees of freedom again, okay? So if you are putting in your values, you always have to show on the AP exam, you have to show your values plugged into the formula. But once those values are into the formula, you can jump straight from that right to saying, hey, this is the test statistic. Okay. And then if you report that test statistic and this p-value, you have to report this degree of freedom. Okay. If you do the one from your calculator. Now, this will always be the t-test statistic, so you can report that whatever. But if you find your p-value using t-CDF, then you have to input your degrees of freedom as a whole number. So you would input degrees of freedom as 34, and you would get a slightly different p-value, although you'll notice that this p-value is so small. You're also going to get a p-value that is very, very small, okay? So in this situation, it didn't really make a difference, but when you are writing down your work, it definitely matters. So just make sure that whatever p-value, if you're reporting the p-value your calculator gives, you are also reporting the degrees of freedom your calculator gives. If you're using t-CDF and you're using the conservative method for degrees of freedom, that you are reporting those degrees of freedom as well. Okay. All right, that brings us to the end of the calculator section. Now we are going to go through and talk about how we choose our inference method. So there's always a lot of great kind of organizers out there to help you think about this, but I've kind of simplified it down here. These are the questions you should ask as you go through and figure out which inference method am I using. When they're all mixed up together like they are going to be on the AP exam, how do I know which one to use? So your first question when you see a problem should be, what are you performing inference about? Do you have means or do you have proportions? Right? The type of data you have narrows down the test significantly. Okay, so are you working with means or are you working with proportions? Once you get there, then you actually ask the next question, are you working with one group or two groups? Do you have one sample or two sample here? So let's say we have proportions and we have two options. We either have one group, one proportion, or we have two independent groups. Okay. From there, then we need to see, do we need an interval or do we need a test? Okay. So if we have one group, our next question would be, are they asking for a confidence interval or are they asking us to run a significance test? And then we would do that appropriately. Okay? Same thing with the two independent. Okay, are we going for an interval or are we going for a test? And then that chooses the inference procedure for us. For means, one or two groups, you actually have three options here, right? We have the one sample, we have the two sample, and then we have a matched pairs experiment. Okay. Now this matched pairs, these paired t-interval and a paired t-test, those are actually just the one sample t-intervals in the t-test. Okay. Just the way we set up our problem and the way we get the data, it's going to be a matched pairs experiment, but actually performing the inference procedure, it's the same as a one sample t-interval or a one sample t-test. Okay. But we do have to make sure we identify that correctly. And I use T for all of our means because that's just the most common. Remember, we do have our Z options if we know the population standard deviation. For proportions, it's always going to be Z. Never use your T distribution for proportions. Okay, we're going to finish up with an example here. For the following problems, identify which inference method you would use to answer the question. So here are all of our inference methods. We're going to go through and follow that flow chart to decide which one is which. Okay, so this is going to be our first problem. Researchers want to estimate the difference in average systolic blood pressure between men and women and provide a 95% confidence interval for this difference. So first, what is our data? Is it quantitative or is it categorical? Average systolic blood pressure, that's going to be means. Okay, so that's the first step. Next step, is this one group or two groups? Well, if we want to know the difference between men and women, that's going to be two groups. Okay, and then next step, which inference procedure are we running? Interval or a test? And in this case, it's an interval. So means, two groups, interval. That tells us it's a 2-sample t interval. Okay, so those are the three things we want to answer before we decide on which inference method we are going to use. But they give us all of that in the problem, and we can decide just based on that information. Here's another example. A surveyor wants to estimate the proportion of customers who are satisfied with their service, and they want to provide a 95% confidence interval for this proportion. Okay. Well, there you have it right there, proportion, right? Proportion of customers who are satisfied. It is a one group because they're just looking at their one group of customers, and they do want an interval. So this would be a 1 proportion Z interval. Next, a researcher wants to estimate the mean cholesterol level in a population and calculate the interval for it based on a sample. So we're working with means, mean cholesterol level. We have one group because they just want in a single population, and they want to create an interval. Okay. So this would be a 1 sample T interval. Okay. If you want to try these on your own, feel free to pause before I give you the answer at any point throughout the video. But I'm going to go through the rest of these examples and the rest of the answers now. So an economist wants to estimate the difference in proportion of two different regions that support a tax increase and provide this 95% confidence interval for the difference. So we are looking at proportions. They say proportions in the problem. We are looking at two groups here, and it does want an interval. So you got to think proportions, two groups with an interval. That's going to be a 2 proportion Z int. A fitness coach wants to determine if a new training program significantly changes the running time of athletes by comparing their times before and after the program. Okay. What one is this? Well, we're looking at means because we're looking at the running time. Okay, so we're comparing their time. Now, are we working with one group, two group, or is this a matched pairs? Okay. So the way this is set up, this is going to be a matched pairs. Okay? And there's not a lot in the wording. I understand that. But the way that leads me to believe this is matched pairs is because we are going to compare their times before and after the program. So meaning every athlete is going to go through the training program, and we are going to compare their before and after. Okay. This is going to be a test because we want to know if it significantly changes the running time. So we are going to do a paired t-test for this. Okay. The next one, a psychologist wants to estimate the mean difference in stress levels before and after a course that they have within the same group of participants and provide a 95% confidence interval for that mean difference. So this is a mean difference, okay, mean difference in stress levels. This is going to be a matched pairs because they specifically say the same group of participants, and we are going to be creating an interval. So this is going to be a paired T interval here. All right, the last 4 situations here. A teacher wants to know if the average test score of her class is different from the national average. So this is going to be means because we're working with averages. It's one group because she's looking at her class, and we are going to do a test because she just wants to know if it's different from the national average. So we're going to do a significance test, which is going to be a 1 sample t-test. A medical researcher wants to compare the proportion of patients who respond to 2 different treatments to determine if there's a significant difference between the treatments. Okay, so compare the proportion. So we're working with proportions. We're comparing it between 2 different treatment groups. So it's 2 groups. And if there's a significant difference, we want to answer this with a test. So we're going to do a 2 proportion Z test on here. A company wants to compare the mean productivity of 2 different departments to see if there is a significant difference. So mean productivity is going to be working with means. 2 different departments means there's 2 groups. And we're looking at a significant difference, so we're going to be running a test. This is a 2-sample t-test. And then the last one, a political analyst wants to know if the proportion of people who support a new policy is different from 50%. Right? So we're looking at proportions, proportion of people. We're looking at one group because just the proportion of people, and then we're running a test. We want to see if it's different from 50%. So that's going to be our one proportion Z test. And there you have it, folks. That wraps up our series on Unit 7, Inference for Quantitative Data Means. Thank you guys so much for following along in this series. Our next series is going to be talking about Unit 8, which is all about the chi-square distribution and all of those inference procedures. So thank you for following along. If you like this video, please click the like button and subscribe to my YouTube channel for more great AP statistics content. As always, thank you so much, and I wish you endless statistical success, and I will see you in the next video.